Yes, yes.
So you guys know, right? AIGeeks.net. That's where this presentation is already present. I can just do it again. AIGeeks.net goes into tutorials. Here you have all the resources, and also this is what I was talking about, topic modeling of Donald Trump tweets. So this is a repository already available. But before even going there, we'll try to go and see what is the basis of it. Try to understand the very basics of natural language processing. Those who have already done it, probably they feel pretty slow, but please bear with me on the same. Okay, so these are the links we have, which you can use to scrape Twitter data, or you can call website, and you can create your own data set. Or you can use some existing data sets available on internet, which is already cleaned and already done well, so you can use those as well, right? So I'm not stopping you to use the existing database. I'm just giving you an idea of how you can create your own database using old tweets. Once you do that, your data will be either in a CSV format, and you need to do it in pandas. I hope most of the people here might have heard about pandas. So it's a very basic command, read CSV. You can, if you don't like a CSV format, like you like a Parquet or other formats, please go ahead and use those formats. I personally prefer Parquet, but for the initial level to debug and you try an algorithm, you might like to use CSV. Once this is done, this shows how you can join and create your own data frame from various files. So this is just like, suppose you have a website which is publishing an article, right? Say, and you are getting tweets and from a JSON format, let's say. So you can use this as a suppose your web service, you are subscribing to a web service, it is returning a JSON format. You can use this code to create a data frame based on various JSON files. So, now the question is, should we convert JSON in or CSV into dict? Dict is dictionary in Python. If yes, why? I just want to go through a dictionary is Python's key value pair. So once you convert into dict, it appears to be a bit faster. So if we go here in our code, we are using data frames. You can definitely go ahead and convert into dict, and it does Python pandas. You can do it very quickly. So go ahead and try this on your own, and even if you don't want to use dict, it's okay, but my personal opinion is it appears to be a bit faster. You are completely free not to use dict. So here is what we're trying to discuss first is tokenization. Now you crawled the website data or Twitter data, and now you want to break into tokens. Why we want to do in a tokens? Because NLP algorithms do want to get this data in a tokenized format. We'll come to it when we discuss something called bag of words. And bag of the words is just a bunch of words which are put together, not in a particular order. And so here is a code which allows you to tokenize using Python library. There's tokenizer. It is from coming from NLTK tokenize. You try to do it in a lower case to avoid duplications and make everything to one. Once it is tokenized, you will like to remove stop words. Stop words are commonly occurring words which doesn't really give any semantics to the natural language processing you're trying to do. For example, you want to understand the correlations between various tweets. You need to do what topics they belong to without any tags or hashtags. So how you do that, you will try to do take into tokens and remove all the commonly occurring words like which really don't appear. But sometimes it is not a very good idea. For example, Thor the Ragnarok is a single topic, but if you use tokenization, it will remove the, and it will take Thor and the Ragnarok as two different words. And they might be belong to the same topic, which we will explore how it can be done. But sometimes not a good idea. So it comes with its own challenges. Now, how to do this stop words is very easy. There is a library in Python called stop words. You just import it, and there are variously available languages. You can use those stop words, get stop words for that languages, and it will automatically remove from your tokens which you've generated using regular expressions. Questions is, why can't we load our own stop words in the list? Yes, you can do that. You can have your own stop word list designed for a particular application. For example, you are doing a scientific literature and you want to have your own set of stop words which is pertaining to that domain, like medicine. You would like to have those stop words in place. So yes, you can definitely, if you're doing a very specific natural language processing like medicine or law, you should have your own stop words. One quick exercise: add a manually add Malay language in stop word corpus. Now, what has happened is stop word corpus is increasing, but sometimes some languages are missing. For example, some natural language, Indic languages might be missing. So probably you want to have, you can fork the stop word repository from GitHub and add your own language. Okay, anyone tries to say something? Let me just go back. Okay, if anyone wants to say, let's go to meeting chats. Okay. Okay, guys, I know you're sharing a chat link. That's great. That's okay. And I think we take it seriously a bit here. We are really running short of time here. Okay, great. Now, we would like to discuss LDA. So LDA, before I go in the details of LDA, here is LDA. So, okay, just skip few words here. Okay, so I think, okay, after stop words, I think we need to go to a, there are some algorithms called stemmer algorithms. The idea is stop words are great, but how do you say these two words belong to the same root word? For example, compute and computation belong to the same word. So basically they are the same word, so they may belong to same computation. So instead of putting as two different words, if you want to improve the accuracy of your model, you probably like to drill it down to a root word, which is compute. So one of the approaches is Stemmer's, part of Stemmer's algorithm, which has a bunch of rules for reducing a word. And whenever the conflicts, the longest rules win. But this is a really bad idea because there are so many rules in English languages, and it is not really, sometimes it gives you a disaster in the results. So Porous Stemmer is hardly used these days. People have come up with different approaches in different languages. It might work for some languages which are still very grammatically oriented. For Arabic, I think it works perfectly well. We're discussing here, right? Yes. So Porous Stemmer algorithm is the one here is the code, very simple, but I would rather not use this. As you can see, it results into a very bad results, like humble is reduced into L. So it is not really a very efficient algorithm. Now you can do any snowball stemmer, and you can implement your own. Certain languages doesn't have a snowball stemmer, like Malay language. You guys can implement your own if you want to, but you can do in your own languages, but there are already many languages included, so I don't think you need to do that. Lemmatization goes one step further, like they uses obtain the grammatically correct word and distinguish word by their word sense with the use of it. It's much more difficult and expensive process than stemming. And it is like you have a various tenses in words. Suppose you have someone who says fabricated and fabricate. So you will try to distinguish words by their word sense with the use of vocabulary. So it's more grammatical, right? So for example, this is a lemmatization example. Every man dies, but not every man really lives. Now, if you remove the stop words, it is becoming man dies, lives. But when I do the lemmatization, what really happens is it is reducing the into actual verb and actual nouns which are relevant rather than having different forms of the verb. So that key gives us a key example. But sometimes it might in a long run, we don't want to do this when it comes to neural network because it is also losing some context when you do this kind of lemmatization reduction. So probably not a very good idea in a current NLP state of art. This is one example how to do the lemmatization, right? So you can very quickly do your lemmatizations and you can use this code. That's great. Also, you can do some more thing like what is the frequency of the words, what is the frequency distribution of the words. It gets a basic idea like which words are most occurring. Maybe they are the maybe they represent the topic itself. So from that idea that maybe the frequency or the distribution of the words plays a key role in topic modeling, came certain approaches. So let's take this example, and this is a bag of words, right? And once you have this bag of words, you would like to have a frequency distribution. Like you're saying, hey, it is appearing 6 times, I is appearing 5 times, and you see most of the stop words are appearing more times, but the real ones are appearing, which contributes to the topic itself only once. So maybe if you remove the stop words and then do a frequency distribution, it makes more sense. That because you will get the repeatedly appearing context many times. So this is the idea of having a bag of words, and you can do it yourself using these commands. Once you have done this, right, you can implement this by yourself, right? I take this corpus. So this is any document can be considered as a corpus. I can transform the corpus into guys, please mute please, so that I can continue. I don't know who is speaking again. You need to stop sharing. Sorry. Guys. Okay, I think it's all okay. Okay, so a few of the models we have is LDA, which is Latin Derelict Allocation, LCI, LSI, which is Latin Semantic Indexing. TF-IDF is Term Frequency Inverse Document Frequency. I will see into it. Then is Doc2Vec, which is a deep learning method of modeling and finding the similarities between documents. So we will try to see if we can finish all of these, but yes, I will try one by one. So LDA is Latin Derelict Allocation, basically saying that, hey, I have a distribution of words in a topic, let's say number of topics are 50. So what is with the probability of topic occurring in document D, which is, let's say, 5,000. So basically I'm saying, what is the probability of distribution of this given set of words of it, which has these topics. So each topic may contain these words. Okay, some chat, please. Okay, chat. I don't know. It will just squeeze this live stream. Oh, nice try. Okay, I'll continue. So mechanism, and the mechanism is a very special kind. It's a multivariate, means multiple variation, generalization of beta distributions. Now, there are various kinds of distributions in probability density functions, which is a kind of advanced mathematics. We can go through it, but the whole idea is we are getting a probability distribution of a given set of words appearing in a given document based on my past document history. That's the basic gist of it. And based on that, I can say, hey, a new document arrives, what is the probability it belongs to which topic based on the words it has. So that's a very basic gist of it, right? And the people behind LDA history is David Blay, Michael Jordan, not the basketball player, Andrew Ng, I think everyone knows from Coursera. So these are the people who are behind LDA when it came into picture. Let's take a very simple example of LDA. Let's say I spend the evening watching football, I ate nachos and guacamole, and I spend, the third sentence could be, I spend evening watching football while eating nachos and guacamole. Now you see that in the natural language processing, first topic is basically watching football, second is eating nachos and guacamole, but third sentence contains both of the topics, right? So sometimes this LDA algorithm will give you something like this, okay? Topic 1 is basically watching football, which is 100% A. Topic B is eating nachos and guacamole, which is 100% B. Then it can give you a probability distribution. But it also tells you that topic 1, 50%, if it's footballs, then it's a 50% chance it belongs to topic 1. If it is the evening, it belongs to a 50. So there is a distribution of the words itself. It's not just, and these distributions are interrelated. So we will go further and understand how it really works. So basically, anyone have heard of Bayesian networks? So Bayesian networks is saying, okay, what is the probability of something happening given that thing is already there? For example, I know the probability of raining is 20%, and probability of sprinklers and rain, turning on the sprinkler when it's raining has been given as well. Now, what is the probability that the grass is wet due to rain or due to sprinkler? So we can have this kind of probability distribution, which is usually called truth tables, to come to a conclusion. And this is what is happening. Given that these words are there, what is the probability it belongs to the given topic? Right. So this is at the gist, it's a US chain application of probability distribution. Guys, can you please mute? I think it's just, I don't know who is there. I need to mute Gayatri. I'm muting you. Okay, that's fine. So I will go back to my slides. I don't know where we were. Okay, I think here we are. Okay, and I'll just start sharing again. Share. Okay, so we are back. Now what we're saying is this is the probability distribution we have, right? So LDA is basically a continuous chain application of Bayesian network. That's it. What is the probability of given two words has occurred, and you just apply the chain rule of Bayesian probability. That's it. Yeah, so you can see that this is just one basic distribution that you can say, okay, it belongs to these topics based on a document, and it's very much used in a medical journal analysis or scientific journal analysis, that given if you have a given set of papers, how many topics they cover and how they are interrelated to each other. So this is a very simple LDA, which is saying a unigram distribution of 3 words only, and there are 4 topics. So when you plot this on a graph, you will see something like this, where you have 4 topics, but there are only 3 words. And it is quite possible that only 3 words can end up forming 4 topics, because you can combine 2 words and make 1 topic, and you combine 3 words and you can make another topic. So this is quite possible. Once you do that, you will give us something, a probability distribution function of like what is a probability if this word belongs. So here is a probability distribution of each topic belonging to a 1, right? One word forms 1 topic, but when they all occur together, they form another topic, which is known as a center, as a peak in the center. So that forms the 4th topic, right? And this is basically what LDAs, when you plot LDA distribution, it looks like. You can go to the papers of Andrew Ng, and which was presented in NIPS conference, and you can go and look into it. Okay, so organizing your code is very important. Once you understand how you do this, organize your code. Your data could be coming in JSON, or you could be converting into a dict. You could be using pandas data frame, or you can use the CSV. Right? How do you do that? There are so many options here. I'll leave it to you guys, but I prefer dict. So that's what I'm doing here. I'm loading the data from JSON or CSV into a data frame, but ultimately I am converting into a dict. So which is what is happening here. I'm taking those, as you've seen the JSON code earlier, I'm taking the data frame, iterating it over and converting into a dict. There are definitely many advantages of storing in process data in a dict instead of DF. I'll come to that. We have discussed in the past. And so once I do this, I will store it in a particular format called PickleDam, right? So it's a binary format where I can store the file. Why I do that? Because I want to maybe reuse later on, right? So I can easily reuse. Here is some of the code to reuse. Okay, we don't have much time left, I guess. Next is a very important package, we know that, which provides all the models to you, right? So most of the models like LDA, LSI, also Word2Vec, all these models are already available in Gensim. So here what I'm doing is I'm creating a dictionary using the, whatever text I have, which I've already removed the stop words, I've lemmatized it, I've done all the pre-processing required. I have converting into a dict so that I have a very refined set of the words, a dictionary, right? And once I do this, I can convert into this dictionary, using this into bag of words, right? Which is I want to do Dr. Bob bag of words. And once I do this, I can pass this corpus and number of topics I want to have, and dictionary and random step. Interesting question for all of you would be how you decide number of topics, right? You have, let's say, Donald Trump tweets. Donald Trump tweets about so many things about every day, right? So how you decide how many topics he's talking about? Where is the topic limit stops? And to answer the question is you need to think of dynamic topic modeling, but this is something is in a different domain, which we'll learn later, right? Yeah. So this is one of the exercises you can try printing dictionary and corpus and understand its structure. This is very important that because this is all done internally and probably you use this code, but you'll never understand what is getting happen inside. So try printing the dictionary, trying to print statements and see what it is, what did it really look like, right? That would be interesting to understand. Once you do this, right, you want to get the similarities between the various documents that has been created, right? So remember, we took the data frame and converted into each frame into a single dict, and that's important, right? Because that's what we're trying to do here. Once I have done this LDA model and passing it to matrix similarity, it gives me the similarity of those various documents. And I can, since I have those dict keys, I reload it, right? And once I reload those dict keys, basically I am able to find the similarity of a given document to the various documents in my corpus. So that's why the key comes in very much in handy in creating a rather than you hard coding it, and it's very efficient in that way. However, this is not sorted, right? So you can always use sorting mechanism in Dict. You can sort that by the various ways, right? And by I think you would like to sort it by the similarity score in a reverse order. Uh, Again, this is all to figure you out. Of course, it's there in Donald Trump tweet analysis. You can take it from there as well. Once this is done, you can get the document ID. The similar thing happens in similar code structure is there in LSI, but LSI differs in that it is based on a principle that the words that are used in the same context tends to have a similar meaning. So it is using a very different technique called singular value decomposition. We can come to it, but try to understand it is just more like instead of it's more closer to deep learning and vector analysis. So this is what is happening basically here. Singular value decomposition. You have a unit vector, you have a vectorized, and you have a diagonal vector developed for your data set based on your distribution, and it gives you a something similar distribution, probability distribution. LDA does it, but the concept is more matrix based, and that's where it differs rather than probability density function based, which is the basis of LDA. Yeah, you can use it. I think it's easier to do. And TF-IDF was a earlier method which is used for like how, based on the numerical statistics, how important a word is to the document or in a collection or corpus, right? So basically, what it's trying to do is frequency of a term which is appearing, which is occurs in a document D, and a number of times the term T appears in a document D, or the number of words itself, right? So this is term frequency adjusted for the document length, right? And inverse document frequency is how much information the word provides, right? So where the information is common or rare. So some documents could be very small, right? So what does it really mean? Maybe that it doesn't really provide much information. So here is a formula for it. A log of number of documents divided by total number of documents by the number of documents containing a term T. So we are talking of a particular term T. So let's say a number of documents is 5,000, and total number of documents by having by the number of documents containing a term T is around only 300. So log of 5,000 by 300 is, or let's say, to a question and answers today. So I'll stop here. The reason is very clear. I want you guys to see this code, which is there in Donald Trump tweet analysis. So here is the same code which has generated by LDA and LSI, and you can use most of the code, right? So you can see that what it is trying to do. It has a limitizer in a place, and it has all the things done, right? Most of the pre-processing, and it will show you how each dict is looking. So you can see each dict has been arranged by a timestamp, because we assume that a person can tweet only once in a single second. I hope so. Some people, bots can do more, I guess, but a person will definitely do one. And once you do this, I have printed all the tweets. I think we have gone through them. So there is a bit of code. I think it has not loaded yet. Yes, yes. Yeah. So there is a bit of code down where you can fork and see because it's a long GitHub file. So you can see how the code has been organized and reused. So that's it for today, I would say.